Assalamualaikum and a very good day to Dr. Zana and my fellow friends. So I'm from group SEAC. We'll be presenting methods of predicting wax or paraffin precipitation and deposition. So first of all, let me introduce myself first. My name is Nur Shafika Akila binti Nurizam, and I'll introduce few others of my group members, which are Emma Julana binti Effendi and also Nur Atika binti Ismail. Okay, so without further ado, let's start with introduction first. So under introduction, I will discuss a little bit about the factors that promoting wax precipitation and also consequences of wax precipitation. Okay, so there are some of the factors of wax deposition. Some of them are temperature, flow rate, crude oil composition, and time. Under temperature, based on a open access journal, lower temperature of pipe wall or lower temperature of crude oil or lower ambient will cause higher wax deposits. Okay, this is a major drawback for offshore oil production because the subsea pipelines are vulnerable to low temperature of the sea. Okay. Okay, next is flow rate. Decreasing flow rate increases the wax deposition. This is because when the flow rate is low, it will somehow making the crude oil more easy to in contact with the low temperature of the pipe wall. Okay, next is crude oil composition. So based on this same journal, which is open access journal, light oil tend to form solid hydrate at low temperature and high pressure, whereas heavy oil tend to form wax at low temperature. This is because heavy oil contains heavy compounds like N-paraffins, one of the components to form wax. Okay, lastly, it is time. Based on the same journal, increasing operation time increases the wax deposition because the wax is actually in a gel form at first, okay, initially. So as the operation time increased, the gel form wax will harden as a part of aging. Okay, next I will talk about the consequences of wax precipitation. This is why it is so important to avoid the wax precipitation in early production. One of the consequences of wax precipitation is decrease in production rates. It will cause equipment blockage, and under severe cases, it will cause production to shut down. Okay, as you can see the picture here, this is the wax deposit. Okay, this is the kind of like slug, this is the wax deposit in the tubing. Same goes to this. As you can see, it's kind of like gel form, and like this one, it hardened because it has been left for so long inside of tubing. Okay, next I will pass this slide to my team members to explain the methods of predicting wax precipitation. Thank you.
Assalamualaikum and hello everyone. My name is Nur Atika binti Ismail. As for today, I'm going to present my part, which is the several methods that are available for predicting the wax or paraffin precipitation and deposition. So let's begin. Okay, the first one is indirect measurement method. Physical quantities that being estimated in this method are volume, pressure, electrical capacitance, temperature, and ultrasonic signals. The volume fraction of the deposited wax can be determined by the change in volume. As for the pressure, the difference for the of the deposited wax or paraffin. However, this method is invasive, thus non-destructive techniques are used. So there are three techniques involved, which are temperature-based techniques, ECT, and ultrasonic form. So first, technique is temperature-based. Thermosensing utilizes the heating pulse applied externally, and its transient response can assist in real-time assessment and monitoring of wax deposition. Information about wax thickness is collected by observing the acoustic signals. And for the ECT is electrical capacity measurement that provides high-quality image by applying complex algorithm. It is experimentally examined on the non-metallic transport pipe, proving that monitoring wax precipitation and deposition via online can be achieved. The last technique is by using ultrasonic form. In this technique, decay time of ultrasonic signals can provide information which can be correlated to deposited thickness of wax. Overall, among all these approaches, ECT is in the focus of the inquiry to discover its capabilities. Next method that is used for predicting the wax of paraffin precipitation and deposition is high temperature gas chromatography (HTGC) method. Gas chromatography is used to separate complex mixtures of different molecules based on their physical properties. It is an ideal tool to analyze gas and liquid samples containing many different molecules, allowing to identify both the types of molecular species present and their concentrations. So gas chromatography, that is more than 350 degrees Celsius, can be categorized as HTGC, high temperature gas chromatography. HTGC method is accurate and suitable as first step to characterize residues and feeds used for conversion process. It enables the analysis of a wide range of molecular weights from C7 to more than C100. Separation of N-paraffins, isoparaffins, and cycloparaffins has been done through dimensional GC with flame ionization detection or a time-of-flight mass spectrometer. The next method is ultrasound and laser spectroscope. This method is used in determining the presence of small solid particles and paraffin within paraffin-containing oil samples. This method is only performed at a laboratory scale. Thin layer chromatography with flame ionization detection, the LC-FID, has been utilized to describe and detect petroleum-associated resources. A simple method depends on TLC-FID is used to detect wax content in petroleum products, which also includes a two-step development with N-heptane and methyl ethyl ketone as solvents. Saturates are separated from components based on their high solubility in N-heptane and low interaction with silica. MEK is then used at a low temperature to separate the waxes from the saturated portion. So the last method for my part is near-infrared scattering, NIR. This method is used to measure the wax appearance temperature, WAT, under non-quiescent conditions in crude oils. NIR attenuation measurements at a wavelength of 1100 nm can theoretically detect wax crystalline less than 55 nm in size within Rayleigh scattering limit. So what is wax appearance temperature, WAT? WAT or cloud point is the temperature where the first wax crystal begins to precipitate out from the crude oil. The result of WAT varies depending on what technique is used. In near-infrared scattering, WAT measurements are the demonstrated using waxy crude oil and gas condensate, as well as model fluids consisting macrocrystalline or microcrystalline paraffin wax dissolved in dodecaned, and IR yields WAT values similar to the classical CPM technique. It is an suitable way for measuring the time necessary to melt paraffin wax solids from waxy petroleum fluids at warm temperature and under non-quiescence processing conditions. So the figure shows that wax contains API gravity, wax appearance temperature, and pour point values of waxy crude oil from diverse regions. So that's all for my part. Thank you.
Hello and a very good day to Dr. Razana and all my fellow friends. So my name is Emma Juliana Binti Effendi from EH2435B. So today I'm gonna explain more about the method for predicting wax or paraffin precipitation and deposition. Okay, the method that I covered is a wax crystallization. The function is to determine the temperature at which the wellbore first produces wax precipitation. Uh, Wax deposition is influenced by the process of molecular diffusion in which the waxes first precipitate at the cold walls of the pipeline. So after this process, it will create a radial gradient of deposit causing precipitation. So this can contribute to a powerful interlocking waxy crystal network that create pipelines blockage and drastically affects the behavior of the rheological fluid. So in the oil, gas in solution functions to some degree as a wax solvent. So the loss of solution gas increases the temperature of wax crystallization. So if the temperature in the wellbore is lower than the fluid crystallization temperature, wax will start to come out and become accessible on the wellbore for deposition process. Okay, the next method is a smart algorithm, which is to stimulate the connection between the rate of wax deposition and the contributing factors based on the input of the raw data. So, a different model for the prediction of wax deposition based on simulation by smart algorithm have been extensively implemented with the advancement of computer technology over the years. So this method predicts wax deposition in such a way that under different functional conditions, wax precipitation can be calculated using suitable machine learning algorithm. So we can take an example. For instance, Zhou et al. Use backpropagation, which is BP neural network, separately and gradual regression analysis to evaluate wax deposition rate models, demonstrating a higher accuracy of the model based on the BP neural network. So for the next example is from Behbani et al. Use an artificial neural network (ANN) model associated with multi-perceptron topology to account for the value of precipitated wax and indicated that this approach was more efficient than the solid solution or multi-solid phase model. Sorry. So, based on the factor regulating wax deposition, the RPF neural network model was used to forecast the wax deposition rate, knowing that the three-layer RPF neural network has strength in nonlinear fitting and self-learning ability. So, uh, so this is the network structure of RBF neural network. You can see here is x1, x2 until xn. So this is the first layer, import tier, second layer, hard tier, and the third layer is the export tier. So the three layer RBF neural network has strength in nonlinear physics. So for the next method is heat fluid coupling is to stimulate under various fluid generating intensity and moisture content. So the most significant influencing factor in the temperature sector are the fluid generating intensity and moisture content. So with various fluid generating intensity and moisture content, the temperature field is experimentally verified. So under the forming state, the wax has normally dissolved in the crude oil, but it can be precipitated and deposited with a reduction in temperature. So by comparing the well temperature area and the temperature of wax precipitation, the wax location can be determined. So the temperature drop rate becomes slow from bottom to top with the growth of fluid producing strength and moisture content. So last but not least is wax deposition model. So it's to predict and track wave deposition either directly by numerical estimation or using software with a back-end mathematical model. So model of wax deposition are constructed based on interpretation, analysis, and parameter selection. So there are four main models in order to predict and monitor wax deposition. So, okay. So this is the four model. The first one is the film mass transfer model, FMTM. The second is equilibrium model, EM. And the third one is Matzane model, MM. And the fourth is a Van Cartesian's model, VM. So we gonna look at the FMTM first. So FMTM is generated on the basis of the assumption of mass and heat transfer, given that both transfer operate independently. So the second model is EM. So unlike FMTM, EM is built based on thermodynamic equilibrium and takes into account the concentration gradient in the model. For the MM, it's a transform EM model that makes it more efficient by using as an empirical correlation the diffusion equation as well as the aspect specific to shear stripping and trap oil factors. So the last one is the Van Cartesian's model. So VM is mainly built with two coefficients to shear effects along with mass flux quantification in the model. Okay, what we can conclude from the four wax deposition model is MM was discovered to be self-sufficient due to its compatibility with experimental data. It was also attributed to oil entrapment consideration, association of the hearing stripping effect in the model. So this is the reference that I used to finish the presentation and the report. So that's all from me. Thank you.
Okay, now the slide is back to me for conclusion part or summarization. Okay, these are some of the summarization for indirect measurement. It involves thermal sensing and it detects any change of temperature in the oil. For HTGC, it detects heavy hydrocarbons by recording its molecular weight. And then next is ultrasound laser spectroscope. It detects presence of small wax solids by ionization detection in the production. And then near infrared scattering, it predicts wax deposits under active production condition. Okay, and the mechanism is the rank length measurement. Okay, and then next, the wax crystallization method. The mechanism is to determine the temperature of the first wax formed in the wellbore. And then smart algorithms determine contributing factors of wax deposits and rate of wax deposition. The basic principle is the calculations based on models, which is pretty similar to the deposition models method. Okay, lastly is heat fluid coupling. Okay, it determines wax deposits via comparison between the temperature of the well area and wax deposition temperature. So for the last slide, okay, the references we use under for these slides. Thank you. That's all from our group.